I think this was a very good presentation from Ericsson, and it's all about the connectivity and how we actually use the information that this connectivity gives us. And talking about that, it creates a lot of data. And what should we do with this data then? How could we actually take the data and do something that actually makes our companies more profitable or having a better services or whatever better product we want to have? I think that question will be answered by Chris Baker, Senior Vice President from Oracle. Chris, welcome on stage.
By me. So wake me up when it's all over. When I'm wiser and I'm older. All this time I was finding myself in a...
Good morning, ladies and gentlemen. It's a real pleasure to be here in Stockholm. It's particularly pleasurable seeing the sun outside as well. And I think it's fascinating to me that I come to an M2M conference and we talk about cars, which I think is very obvious. I have to say that I found it a little surprising to talk about socks. But there again, I think that one of the things that I want to get across today is about the Internet of Everything. And when I say everything, I mean everything. But to start off with, I don't want to talk about M2M particularly. I don't want to talk about socks. I want to talk about sailing. Let's have a video. So, for those of you who don't know, that was an America's Cup boat. That was the America's Cup boat that won the 34th America's Cup about 6 weeks ago in San Francisco Bay. And Oracle Team USA, it was quite an exciting period because we were running our conference called Oracle Open World, and as Oracle Open World opened, Oracle Team USA were 8-1 down, and it was the first to 9. So we weren't talking quite so much about it. However, it went from 8-1 to winning the America's Cup 9-8. Now, being British, I, of course, would say that one of the major reasons for that was that they changed the tactician from the guy who'd been doing it for some while to a British guy called Ben Ainslie. But actually, there was more to it than changing the tactician. It was really about technology. So let me take you through why this is so important. The America's Cup is an extremely old, and in fact the oldest international trophy in the world. It actually started 25 years before even Ericsson was formed. And it was a very traditional type of competition between international nations. But what's interesting, what has happened over the years, is that this technology moved very slowly to begin with. In fact, only about 12 years ago, a boat was running at something like 30 kilometers an hour. The boat that you've just seen will travel at over 80 kilometers an hour. That change has happened in about 12 years. The things that have changed in the America's Cup boat is technology. That boat that you've just seen, it may look like a racing yacht. In reality, it's actually an Internet of Things test bed. That's what it really is. It has more than 300 sensors across the boat. It runs 3,000 variables, running 10 times a second. And there's a gigabyte of data that goes back to the shore station every training day, every race day. It takes all of the important parts of the boat and allows people to make decisions. Not just the designers. It actually makes sure that each individual sailor has information coming to them depending on their job. You may have noticed in the video that they had a PDA, a waterproof PDA, strapped to their arm. Each individual person who has a different job on that boat gets different feeds of information. Information about what the tension may be of the sails are, what the stability of the hull is, or how they need to tighten things or loosen them slightly. But also information about tides, information about wind, and so on. And that information is very personalized in terms of it being delivered. Some of it is coming on the processing that's on the boat. Some of it is taking information which is coming from the data center behind it as well. It's customized feed of information. It's about taking information and giving it back in different ways to different people. But of course, the other side of it, to get this huge performance, you've got to have this balance between strength and stability at all times, through the design process, of course, but actually in the races as well. And this is where this differentiated the Oracle Team USA boat and allowed it to win, because it not only was about the tactics, it was not only about what you were doing on the water, it was actually about the way the boat was managed as well. So it was a very critical part of that particular winning streak. But it is this new technology which has allowed new possibilities. And I use this as an example of how technology can radically change things. Between 1851 and about the year 2000, things changed. Of course they did. Materials changed. The way that things were actually operated on a boat changed. But the advances in the last 10 years have been quite dramatic in terms of what has happened in the sailing, in the top end of sailing. And I think when we look at this, we're very proud to have been part of winning the 34th America's Cup. And we will continue to do it. But it is about, when we're talking about the Internet of Things, it's about understanding what you need to do to get radical change in businesses. It's about the applications. All the things that I've just talked about on the America's Cup boat are about applications. Applications which deliver data to the individual sailor on the PDAs. Applications that run on the boat. Applications that run in the data center. It's all driven by data, of course it is. But actually it's the application that makes the difference. And these new possibilities, we're here to talk about machine to machine. But we need to think about this from a business perspective. It's not just about technology. It's about what is the real benefit to each individual business which is sitting in this room. How can they find new opportunities and new possibilities? And there are some very interesting things already going on. One of the things which I think is obviously very important is if you're in the oil and gas industry, how can you use sensors to make sure that if there is a gas leak or if there is something happening many hundreds of meters beneath the earth, that you can close everything down and stop a disaster like what happened on the Gulf of Mexico. Or being able to identify criminals so that you can make sure that you have the right response, not overly response, but the right response depending on the situation that you're in. This sort of technology is being used in many parts of the world today. But I guess one of the more interesting things is in the Amazon rainforest, what is now happening is that GPS chips are being embedded in trees. Now, why would you put GPS chips into trees? Well, it's quite straightforward, really. If that tree starts moving, you can be pretty certain that it's been cut down and taken away. Deforestation is happening. And that means that the authorities can react to stop that deforestation. By using ruggedized, relatively cheap chips, you can actually do something which actually fundamentally changes something which is happening to our world. And I think that when we talk about M2M, and when we talk about the Internet of Things, and just as Robert was talking about, as people and things become connected, it does change the world. Because what we're really talking about is everybody being connected to everything. And that is a fundamental change in the way that we operate. It's a fundamental change to the way we do business, and it's a fundamental change to the way you run your life. You will see things, I think the picture about the Pope between 2005 and 2013, it just shows how much it's changed for those people. They can record something which meant a lot to them as individuals, and the technology enabled them to do that. But when we talk about it, we often talk about sensor data. In fact, I've talked about sensor data. We talk about mobile data traffic. But actually, it's more than that as well. Now it's about preferences. Now it's about what's happening on Twitter or what's happening on Facebook, taking unstructured data and being able to link all that together as well, and being able to be in a position to understand how you can make sense of all of that. It's very important when we think about these sort of environments that we are talking about data. Now, when some people talk about big data, they mean lots of data. And sometimes it is about lots of data. There are lots and lots of analysts talking about how much data will grow. Personal view is that it's a massive underestimate. However, what we need to understand that it's not just about the quantity. It's about the types of data, all sorts of different structures of data. But that data is going to drive all the things that we do. It's going to become the electricity of this age. Electricity changed the world, not just because of light, but because of everything that we do. We couldn't be here today without electricity. Data is going to become that. The key is making sure that you can provision that data and you can drive data into the applications. Being able to do something with that data that gives you value at a personal and a business environment. And it is starting to happen in all industries. We're starting to work with people in all of these industries and more in terms of thinking about the possibilities, thinking about the business benefit. One of the things that we think is important is that if it's not about technology, if it is about applications, part of our job as a technology provider is to make it easy and to simplify IT and to think about where we can take that environment. Because if there is going to be something like 50 billion devices connected to the internet by the end of this decade, the vast majority of those will not have screens. The vast majority of those will not be part of the people that Robert were talking about, where we're talking about just connecting people. The vast majority of those are going to be sensors in rooms like this, in your house, in your businesses, when you walk down the street. But we have to manage that complexity. We have to make sure that when we get data to those applications which are fundamentally important, that it's the right data at the right time. Let me give you an example of not the right data at the wrong time. When the financial crash happened about 5 years ago, many financial services companies suddenly realized they had to manage risk very differently. So they collected data from all sorts of sources. One of the problems was they didn't have a plan on what they were going to do with it. In fact, a very well-known CIO, who I won't name, said to me, actually, I am taking data and I'm putting it straight to archive. I'm not actually doing anything with it because I have so much data, I don't know what to do with it. But I'm archiving it because if I do need to go through audit or I do need to go after an event later, I can go back to that data. That's not the right data at the right time. That's a reaction. With the amount of data that you're going to get with 50 billion or more devices, you have to have a plan and an understanding about how the platform will work. So you have to think of this in a standard way. How are you going to acquire and manage that data? How are you going to make sure that everything works together on a standardized and scalable environment which is secure? How are you going to make sure that it integrates with all of the things that have been invested? And how do you make sure that you manage that complexity? Because at the end of the day, it is about money. How do we make sure that everybody gets the best return on that money? But how do you analyze and act in an environment where you can take the right business value? It's not about people taking action necessarily. It's about applications taking action because of information which has come from another application. Now, we've talked about this for a long time. We've been working together from the days when we started in 1977 with a relational database. It is about how can we move different amounts of data around, and we've deliberately, through our acquisitions and our development, we spend over $5 billion a year in research and development about how can we make things work together? How can we make it easy for people to get information, to get data, to move it around, and to get to the applications. So we've been working on this for many years. But I guess I want to start just giving you an example. And all the things I'm about to talk about are available today in one form or another. Now, I want to use this example because it affects all of us individually. All of you go on vacation. And when you go on vacation, you book your flights and you pack your bags and you talk to the mailman and make sure you divert your mail and you think about your pets and what you're going to do with it. And it's a long list of things that you need to do. Alternatively, what you do is that you go to your iPad or whatever it may be and you press the big button on it which says vacation mode. Your iPad links up to your home hub, which knows exactly how everything's linked, and it automatically tells the mailman to divert the mail. It makes sure that your taxi is booked to get you to the airport at the right time, and it also thinks differently about the way your house should be managed. It makes sure that your security system is set up for you being away. It makes sure that actually you've got alerts around the environment, whether it be for electricity, gas, whatever it may be, but also making sure that you don't have to have the house heated to the level of somebody living in it, but down far enough to keep it warm, but just warm enough. And it's actively monitoring that environment. And of course, one of the things that you do need to do, and I'm sorry I forgot about the pets, it also notifies your neighbor where you've already agreed that you'll be going away and they'll look after the pets for you. So you go away, you're on your way to Barbados to go and sit on the beach for a couple of weeks. After you have left and you're supping your champagne on the aeroplane, suddenly the home hub notices that there's a bit of a spike on one of your electricity circuits, in fact the one around the refrigerator. So it looks at that and it thinks, well, actually, what is actually going on? Is this something that's happening just in your house, or is it something that's happening around the network? The point that Robert made about, it's not, when I'm looking for something wrong, I don't have to walk outside and check whether the other house's electricity is working. Actually, it's looking at the whole network. It's looking at whether this is something very surprising. And it just puts it into watch mode. But it gets worse during the night. The reality is that there is suddenly, the smoke alarm is starting to go off. The monitoring service has noticed that there is a very significant issue starting to happen in your house. By the way, you are now just getting to Barbados at this particular point. The emergency services are notified that there may be a problem with your house, and the neighbor is notified because the pets are inside the house. It then knows that the circuit around your refrigerator is the one which is where the problem is happening, so it shuts that particular environment down. Of course, part of what it needs to do is to be able to disable security so that the emergency services can get in. By this time, you've checked into your hotel in Barbados, and you get a text to say, you may have a small issue in your house, but don't worry. The emergency services have already been called, they're at the house, the pets are okay, so don't worry, we'll let you know. So you're sitting there wondering what's going on, but it's okay because everything's under control. So the emergency services have sorted it out, they close this thing down, the neighbor has taken the pets out of the house just to make sure they're okay, and everything goes back to normal. There's been no damage on the house because the emergency services were called early enough that they could make sure that there was nothing too serious going on. The electricity circuit has been closed down. Unfortunately, the food that has been in the refrigerator and the deep freeze is probably not going to be too good when you get back. But actually, there is no problem, and of course, the pets are safe. And of course, what you're then doing is you go back into vacation mode. All this is being done because the applications are driving this particular environment. And of course, a good idea is to tell you that everything is okay, so a notification comes to you. Now, this is a very simple, in many ways, example. All this technology is there today. But let's think about the benefits that are here. For the emergency services, they know what they're going to. They know the sort of things that they need to do, and they're going early. For the homeowner has peace of mind, and that they can continue with their holiday. They're getting the information they require when they get it. For the insurance company, they know that the minimized damage is there and they can adjust premiums depending on what is there. For the security company, they know that because it's all linked together, that they can have safety, that they're only opening the house for the people who can help it. But interestingly, for the service provider, maybe we used to call these guys carriers, but for the service provider who is probably putting together the entire environment, it's a huge business opportunity. Why? Because it's about business value to you as an individual. Now, of course, all this is happening because of sensor information, information that is around the house, information which is passed around the network, information which has come from historical data, information which has come from the utility companies, and so on. It is genuinely everybody being linked to everything. However, what happens if those systems were not linked together? What happens if they were not on a common platform? What happens if you had to engineer every single time a house came on that you had to make sure that it was all customized? It's not going to work. The fact is that platforms have got to be standard. Applications will be different, but you have to have standardization to allow you to do that from device to the data center or the cloud. It's absolutely critical. Because when you go through this, it's a very complicated ecosystem and value chain. Because it's not just about devices. It's not just about hubs. It's not just about the way that you actually look at it, whether you be on an iPad or on a Samsung Galaxy or whatever it may be. And it's not just about what happens at the data center. It's about making sure all of those things can communicate. And the data can pass through each one of those in all directions. Absolutely critical for the Internet of Things to work. I talked about where Oracle has been investing its $5 billion a year. We believe that it is about platforms. The key element is how can we deliver everything from the storage all the way through to the database and the middleware, which allows people to have a standard platform, allowing them to have the security, allowing them to have the scalability, because it's just plumbing. It's just technology to allow people to use the applications. So let me just very quickly go through that test example through these three elements which are critical. So what are the challenges when you're acquiring and managing data? You've got to have that platform, whether it be at the device end, the gateway end, or at the data center end. You've got to be able to update an environment, and you've got to be able to manage all of those devices, all those gateways, and the data center. And you've got to be able to make sure that you push decision-making as far to the edge as you possibly can. Our view is that standardization is critical at the device, gateway, and the data center end. That's one of the reasons why we believe that Java, as a standard environment, is critical in this marketplace. Java is part of what we acquired in the Sun acquisition. But Java is many things. Java is an open source environment. Java Embedded is on devices and so on. But there are 9.5 million developers out in the world who understand Java, the largest community of developers ever. Those people can write applications. It's for any device. You write once and deploy many times. Writing individually to each individual device, which is what you have to do in native code, just won't work with 50 billion devices. You need to write it once, deploy many times. We've developed technology to move event processing, so complex event processing, pattern matching, all the way down to the edge. Why? Because that way you only acquire the right data at that end, and you only move the right data to the data center. And you've got to make sure that you've got scalable and high-performance data management all linked together. Java in the device, Java in the gateway, Java in the middleware allows that integration to go across the environment. Then if we talk about integrating and securing the environment, obviously the challenges in this environment are you've got to have secure communications and data protection. Security in machine-to-machine and the Internet of Things is absolutely critical, because security is only as good as the weakest point in the chain. You've got to have security at the device level. You've got to have security at the data center level. The reality is that you've got to be able to do that in many industries, and I would argue in all industries. For some industries, it's absolutely critical. Things like healthcare, protecting private data is critical. You've got to make sure that only the right device or the right person has access into the environment. And you've got to have consistency. But you've also got to make sure that you can integrate with your current environment as well. One of the things that we're looking at all the time is how do we take things like identity management, which sit in the data center, and how do we drive that down to the edge? And that's part of what we've done with this platform, the Internet of Things. So identity management, access control down at the edge, making sure that you can actually have the data, only the data that you want to move masked, so that only the data that people need can come through. We also need to give scalability. One of the things that we've done by engineering hardware and software together is giving people scalability in a standard environment, out of the box, purely configurable, not customizable. Because you don't have time in this environment. You've got to have the standard platform. And if you use the same architecture, it doesn't matter what you do at the back end. Do you want to run it on-premise? Do you want to run it in the cloud? Do you want to run it hosted? Do you want to match? It doesn't matter, because the architecture is exactly the same. And then if we move to the analytics and the acting side of things, the business requirements are clear. You've got to be able to analyze data, but you need to do it in real time. Many people talk about big data, as I said earlier. Actually, it's about fast data. If you've got this huge amount of data being transmitted around the network, you can end up in the situation that I talked about before. You get too much data, you don't know what to do with it. So by being able to select the data, taking the intelligent data, the smart data, and moving only that, you can get true fast data, and you can get true real-time environments. Absolutely critical. But you've also got to be able to take information from all sorts of different sources, whether it be structured or unstructured data, whether it be from, as I said before, Twitter, Facebook, and so on. And you've got to make sure that you have applications which map into that environment, which are linked together so that they can automatically work. If you think about healthcare, the business problem for healthcare is how do we get people out of beds? By having wearable devices with vital signs monitoring on them. If something goes wrong, you have to act very, very quickly. You have to be able to link all of the applications together, from the monitoring service to the ambulance to the hospital to the doctor's type of environment to the information on that particular patient. All of these challenges are true to a greater or lesser extent in every industry. By investing in the platform so that we can give complex event processing on both ends of the environment, we can deliver that real-time data platform to allow that application to do it. To be able to not care what is happening in terms of the environment, so you can get true cross-platform visualization. And of course, we work very closely with our independent software vendors around the world who are delivering applications at the data center and are increasingly looking at how they deliver applications at the edge, at the device and at the gateway type of environment. The key here is how do we look across all of these industries? All of these industries, we're working with application providers, we're working together to see how can we provide business solutions into these industries. The key is, how do you make sure that the platform doesn't matter? What we believe is that by standardizing the platform, you can concentrate on the business value. And we want to work with people to do that. The Internet of Things will become a reality when people actually understand the business value. What is in it for your companies? How can you become more efficient? How can you go into new marketplaces? If you spend all your time concentrating on the technology, you'll be too late, you'll be too slow, and you'll be too complicated. By looking at this integrated stack, we believe that we can help all of you guys in this marketplace. It's not just about tying people into the environment, because actually it's all open. The reason that I talk about Java, the reason I talk about standards, is it is about a standardized platform. It allows people, if they open up that architecture, it allows them to use that platform in a standardized environment. In reality, it's got to be high performance, it's got to be secure, it's got to be integrated, and it's got to be scalable. But that platform has also got to be supported. The biggest risk to the Internet of Things fulfilling its market promise is if we cannot support the whole environment and deliver that business value. This schematic is basically what I've just been talking about. It's something which I hope none of you have to worry about, because this is just a standardized platform, whether it be from device all the way through to the data center. But the Internet of Things is a complicated ecosystem, and we are just a part of that. Working with Ericsson, working with TeliaSonera, and all the other people who are here, it's the way that we can help you deliver to your customers and to your business. This car doesn't really look like this car, but in reality, it's all about a journey. It's all about how can the Internet of Things deliver something which is of significant incremental value to your companies, but most importantly, to your customers. By connecting up all of these environments, the possibilities could be as good as the America's Cup. How do you go from 30 kilometers an hour to 80 kilometers an hour by the use of technology? Thank you very much for listening to me.